Okay, perfect. Okay, so we can start. All right, so I said first I'm gonna talk a little bit about the homework number 6. You're having a problem with the chain rule. Yeah. So I think there's one exercise left from on Monday, right? About the chain rule. Yeah. So yeah, I'm gonna go over the chain rule, of course. So yeah. So I let's see. Adrian, you're saying you have a problem with the fifth problem. Fifth problem. Let's see. Fifth problem. That's the sine of x plus 1 over x squared minus 1, right? Okay. So let me do something similar to the fifth problem. 2, 3, 4, 5. Okay. So fifth problem. So this is similar to the problem number 5. All right. Okay, so let's say you have a function h of x equals to sine of x plus, okay, so it's sine of x plus 1 over x squared minus 1 in the homework. So let's say instead of sine of x plus 1, let's say it's cosine of x plus 2, right, over x cubed minus x. Right. So this is very similar to the problem number 5 in the homework, right? So anyway, so we have this function cosine of x plus 2 over x cubed minus x. Again, guys, so whenever you want to compute, so you want to compute the derivative, of course, right? You want to compute h prime of x. Okay. So you have, so when you compute the derivative, you have to ask yourself which rule I'm going to apply, right? And the rule you're going to apply depends on the form of the function. So if the function is a product, I mean, you have a multiplication, right? If it's a product, then you have to apply a product rule. If the function is, is a quotient, or I mean a fraction, then you have to apply a quotient rule. So when I look to this function h, so this function h, well, we have a quotient, right? This is a quotient, right? We have a fraction here. They have division, right? So if it's a quotient, then we have to apply the quotient rule, right? So then apply the quotient rule, right? Now, so you need to know what's the quotient rule. So your h of x, there is a function in the top, in the numerator. Let's call the function in the top f of x, and let's call the function in the bottom, the denominator, g of x. Okay, so you have this quotient f over g. Now you want to compute h prime. So we said, because it's a quotient, then we have to apply a quotient rule. So you need to know what's the quotient rule, right? So it's f prime of x times g minus f times g prime over g squared. All right, so that's the quotient rule, because again, my function is a quotient, it's a fraction, then we have to apply the quotient rule. All right. So Adrian, is it clear to you for why we have to apply this quotient rule? So do you see why you have to apply this quotient rule? Yes. Okay, perfect. So like if you take a look to the homework, like you can see like the third problem, the fourth, the fifth, the sixth, let's see, and probably 6, 7, 8, 9, the 10th, problem number 10, all of them are fraction quotients, right? So we have to apply the quotient rule to all of them, right? Now, once you know the rule you need to apply, then of course, so we want to apply the rule. So here, the top, we said this is, so this is f of x, that's the top, and the denominator, that's my g of x, right? That's my g of x. So if you want to apply this rule, right, you need to compute. So in this rule, you see there's a g, there's f, but there is f prime. You see this f prime here? There's an f prime and there's a g prime. In the denominator, it's just g squared. I mean, we know f, we know g, so we have to compute f prime and the g prime, right? So we need to compute f prime first. So f of x, we said it's the top, is the numerator. That's the cosine of x plus 2, right? So what will be f prime? Now, your f is a sum, right? It's cosine of x plus 2. Well, for derivative, when you compute the derivative of a sum, it's not a problem. You don't really care about the sum. So all you have to do is to compute the derivative of the first function here plus the derivative of the second function. Okay, so what I'm saying is there is no special rule when you have a sum of functions. When you want to compute the derivative and you have a sum, so there is no special rule. All you have to do, compute the derivative of the first function here plus the derivative of the second function. All right, so does this make sense to you? So that's one of the properties of the derivative, right? The derivative of a sum is the sum of the derivatives. So anyway, so what I'm saying is you have to compute first derivative of cosine of x. So what's the derivative of cosine of x? Well, then you need to check the formulas for derivative of trig functions, right? So last time, we computed derivative of, or last week probably, we computed derivative of trig functions. And we said, for example, if you have cosine of x, derivative of cosine of x is minus sine of x. So this is minus sine of x. All right. So you need to know that derivative of cosine is minus sine. Okay. Now, plus, this is plus. Then there is constant here. So when I say constant, it means just a number by itself. There is no x with the 2, right? It's just 2. It's just the number 2. So it's a constant. So, and we said derivative of a constant, if you have just a number by itself, derivative of constant is 0. So derivative of 2 is just 0. So this is minus sine plus minus sine of x plus 0. So it's minus sine of x. All right. So does it make sense to you, this derivative of f prime? How I got this f prime? All right. Yes, the g stay squared all the time. The g in the denominator here in the formula, yes, it's always squared. Yeah, absolutely, yeah. I mean, so you see, all you have to do is to compute this f prime, this one here, this f prime, and this this g prime. Now, next we need g prime, right? So first I'm gonna write down g of x. It's this x cubed minus x, right? So now I'm gonna compute g prime of x. So this is a subtraction, right? This minus here, so it's a subtraction, and subtraction, like the sum, it's not a problem for the derivative. There's no special rule for subtraction. So all you have to do is to compute the derivative of the first function here, the x cubed, and then minus the derivative of the second function. All right. So derivative of x cubed, well, that's a power of x, and derivative of a power of x. So you have to bring down this number here in front of x and subtract 1, right? You have to subtract 1. So bring down the 3 in front of x. We subtract 1 from 3. That's 2. So that's 3x squared. And then, of course, there is a minus, this minus here. So here's my minus. And then we have to compute derivative of x. X, this is like x power 1. So it's the same way. It's a power of x. So bring down the 1. And x times x to the power, you subtract 1 from 1. So that's x to the power 0. And x power 0 is just 1. So it's just, so this is x to the power 0. So that's x to the power 0, of course, is just 1, right? X power 0 is just 1. So that's actually 3x squared minus 1 times 1. So that's minus 1. So now, you see, now you have everything you need to compute h prime. You got your f prime, you know your g, you know your f, you got your g prime, and the denominator is always g squared, right? So then I can answer the question. So then my h prime of x would be f prime first. So f prime is this minus sine of x. So here's a minus sine of x times, and then there's g, right? There's g. G is the x cubed minus x, so times x cubed minus x. And then in the formula, there's minus here, right? This is minus here. So here's my big minus. F, right? There is f. F is the top. That's the cosine of x plus 2. So here's my cosine of x plus 2 times g prime, right? Times g prime. And here's my g prime, the 3x squared minus 1. So times the 3x squared minus 1. All right. And as we said, in the denominator, it's always g squared. So it's always g squared. So it's x cubed minus x. That's my g. And I'm going to put the square. All right. So this is always g squared. All right. So that will be the answer. And again, this is very similar to the problem number 5, right? In the homework, we have like sine of x instead of cosine plus 1 over x squared minus 1. So this is very similar to the problem in the homework. So does it make sense to you, Adrian? All right, thank you. Tasha, you said you had questions, right?
Yes, I have 2. I have one for.
Please, yeah.
For the first one.
First one, okay. Okay, let's start with the first one then. So first one, it's just powers of x. So so this is so let's do something similar to problem 1, right? So this is similar to problem number 1, right? So let's say you have f of x. So in the homework, again, it's x fourth minus 4x cubed, etc., right? So let's say instead of x fourth, let's say you have x power 6 minus 12x fourth minus, let's say, 7x cubed minus 4. All right. So, okay, so you have to ask yourself, is this a product? It's not a product, right? There's no product here, right? Is this a quotient? It's not a quotient, right? It's just a subtraction or subtraction, or let's say here you have plus, okay, plus 4. So it's either subtraction or addition, right? So if it's just if it's either subtraction or addition, then there's no special like rule for subtraction or addition, right? So all you have to do is to compute like the derivative of this, the first function here, minus derivative of this, minus derivative of this, plus derivative of this. All right, so there is no special rule here. You don't have to apply any rule here. It's just you take the derivative of each term, right? So first, like, so then f prime of x. So first, you need derivative of x to the power 6. So do you know what's the derivative of x power 6? Daisha?
No.
Okay. Well, that's because, well, this is, this is x to the power 6, right? So that's a power of x. And we said if we have a power of x, I mean, if you have like x to the power n and some number.
So then you move the x in front of, you move the 6 in front of the
Yeah. Yeah, you bring down the 6 in front of x and you
So then
subtract 1.
So then it's 6x to the 7th power. No.
No, 6x to
No,
the
no, 5th power.
5th power. Yes. Yeah, absolutely. So yeah, Austin, yeah, absolutely. So you put the 6 in front of x and you subtract 1 from the power. So it's 6x to the power 5. All right.
And then you bring down the negative, the minus sign.
No. The minus, you mean this minus the negative 1 or which?
No.
Which minus?
The minus of the
next?
x. Yeah.
Oh yeah, of course. So then so there's this minus here. So here's my minus. Okay, that's a subtraction, right? I have my subtraction. So yes, you keep just the same operation, right? You have subtraction, you keep the subtraction. Next, you have a number times this power of x. So when you have a number, a constant, a number times some function, all right, then the derivative, all you have to do is to keep the same constant. So I'm going to keep the 12.
Yeah, and then you're going to put times 4.
Yeah. Yeah, absolutely. So times the 4 times what?
Times x to the 4th power, right?
Not 4th power.
3rd.
3rd power, yes. X cubed. Yeah.
That would be 48 to the x 3rd.
Yes, absolutely. Now, what about the next? So here's there's a minus. Keep just a subtraction. Keep the subtraction. Do you have any guess for the next one?
That would be 7 times 3. X to the 2nd power.
2nd power, absolutely. X squared, absolutely. And then there's a plus. So you keep the plus. And what would be the derivative of 4?
4.
No. Remember, we said if you have a constant, just a number by itself, derivative would be 0. Right? So whenever you have just a constant number, just a number by itself, the derivative would be 0.
Okay.
Okay, so derivative of 4 is just 0. If you have, so you see there's a difference here. If you have a number like here 7 times some function, so you have to keep the constant, all right, times wherever derivative you have, right? But if you have just a constant by itself, just a number by itself, then yes, then derivative would be 0. All right. So then, yeah, so then the answer would be, as you said, the answer would be, so f prime of x. So it's 6x to the power 5 minus 48x cubed minus 21x squared plus 0. So that's your f prime of x.
Oh, so that's the whole answer to the problem, because you don't.
Oh yeah, that's fine answer. Yeah, sure. So that's fine answer. Yeah, that's a fine answer. Yeah.
Oh, okay.
Right. Okay. Now you said you had another question, right?
Yeah, one more. Number 6.
Is that in the second page or 6?
Yeah, the second page.
Second. All right. The tangent of x minus 1 over the second of x minus 1, right? So yeah, okay. So let's do something similar to number 6. This is problem 6. So you have, let's say, let's call the function here instead of f, let's call the function h of x. And instead of tan of x minus 1, let's say you have sine of x minus 1, or minus, let's say minus 2, over, so in the homework you have secant of x minus 1. So instead of secant of x, let's say you have cosine of x, any trig function, right? Let's just say cosine of x minus 1, let's say plus 1. All right. Okay, so of course, this function h, it's a quotient, right? We have a fraction here, so it's a quotient. So this is a quotient, and so we have to apply the quotient rule, right? Apply the quotient rule, right? So does it make sense to you that we have to apply the quotient rule here? So you see, like here for the problem number 1, your f of x, it's not a quotient, right? And it's not, it's not a quotient, it's not a product, it's just subtraction and sum, right? So that's why for the problem number 1, for this f of x here, I mean, there's no, we don't have any special rule, right? All we have to do is to apply the, derivative of a power of x. But here, this is a quotient, okay? So when you have a quotient or a product, then if you have a quotient, you have to apply the quotient rule. So again, as I explained to Adrian, so if you say, let's say the top is f of x, the bottom is g of x. So my f of x is the numerator, and g of x is the denominator. So my g of x. All right. So then we say the quotient rule, then your quotient rule. So then h prime. So then h prime of x would be f prime g minus f g prime over g squared. All right. So so we need, of course, we need the, we need f prime, we need g prime. We know f, of course, g, and denominator is always g squared. So we need f prime first. So my f is sine of x minus 2, right? So my f is it's a subtraction, right? So again, if you have subtraction or addition, there's no special rule. All you have to do is to compute the derivative of each term. So then f prime x. So first you start with the derivative of sine, right? Then there's a minus, this minus here, keep the minus, and then derivative of 2, right? The derivative of 2 here. So now what will be the derivative of sine of x? So like in the homework, you have tan of x and secant of x. So you need to know the derivatives of trig functions. If you have sine or tan or secant or wherever. So for sine of x, we know that derivative is cosine of x, right? We proved that the derivative of sine is cosine. So here's cosine of x. So if you have tangent, of course, so you need to check the derivative of tangent of x. And then minus, and then this is 2. This is again a constant, just a number by itself. So the derivative, it's not 2, the derivative is 0. All right, this is constant. So then cosine of x minus 0 is just cosine of x. So do you have any question about the derivative of f, the f prime?
No, not so far.
Okay, cool. All right, so then we need g prime. So then my g of x is the cosine of x plus 1. So in the homework, we have secant of x minus 1, right? So you need to know the derivative of secant of x or derivative of cosine of x, etc., right? Oh, thank you, Daniel. I got you. Thank you. So now I want to compute g prime of x. Right? So then, as I said, here this is it's just a sum, right? So first you have the cosine, and then there is a plus, and then you need the derivative of 1, right? So derivative of cosine, we said it's minus sine, right? And then 1, again, it's just a constant by itself. So it's a number by itself, so it's a constant, and derivative of constant, again, it's 0. So then g prime of x is minus sine of x. Right, so yeah, so I got my f prime, I got my g prime, so I have to plug everything in the formula. So then h prime, the answer. So my h prime of x, that will be first, I have f prime. So here's my f prime. We said it's cosine of x times g. We know g, right? It's cosine of x plus 1. So times cosine of x plus 1. Minus, because there is a minus here in the formula. So minus again here. There's f, this f here. So here's f. It's sine of x minus 2. So minus sine of x minus 2. And then times g prime. And here's g prime. It's minus sine of x. So here it's minus. So it's minus sine of x. Right? That's my g prime. All right, and then everything, of course, over the g square. So it's over the cosine of x plus 1 square. All right. Actually, you can try to simplify this answer because, as you can see, like you're going to have cosine square, and here sine times sine, that's sine square, and minus minus, that will be plus. So like here, you're going to have like cosine square plus cosine square plus sine square, and that will be equal to 1, right? So here, there's a way to, simplify the top. So yeah, so you have to try, to simplify your derivative. So like here, h prime of x. So if you distribute this cosine of x times cosine of x, and then cosine of x times 1, so that will be cosine square of x plus cosine of x times 1. That's cosine of x. All right. And then there is sine times sine, and then the 2 times sine, right? So it's sine times sine, that's a sine square. Minus minus, that will be plus. So it's plus sine square of x. And then there is this minus here, minus minus. So that will be a minus. Minus times minus times minus, that's a minus. 2 times sine of x, so 2 sine of x, right? Over cosine of x plus 1 square. And again, here, I'm trying to simplify my h prime of x because, as you can see, I have cosine square plus sine square, and that's equal to 1, right? That's a trig identity. Cosine square plus sine square is equal to 1. So then my h prime of x. Oh, thank you, Robert. I got you. Thank you. So cosine square plus sine square, that's 1. And then we have plus cosine of x, and then minus 2 sine of x. Right? So here, again, I'm using the fact that cosine square of x plus sine square of x is equal to 1, right? Over cosine of x plus 1 squared. Okay. So yeah, so you need to try, I mean, you need to try to simplify your answer when it's possible, right? So like here, as I said, because I see that there is cosine square plus sine square, and that will be equal to 1, right? So I can simplify my h prime of x. Anyway, so that's the answer, right? So the goal, the goal of the exercise, like in the homework, is, is to apply either the quotient rule or the product rule. And sometimes, like as I said, like in the problem number 1, it's not a quotient, it's not really a product. So all you have to do there in the first problem is to, compute powers of derivative of powers of x. Is there any other question, guys, about the homework?
No.
No? Okay, perfect. All right, so yeah, so someone asked me about the chain rule. I forgot who was, yeah. All right, anyway, so yeah, we didn't finish, so that will be section, I think, that's section 2.5, right? So okay, so let me move here to the section 2.5. Thank you, Emma. Thank you. So section 2.5, again, it's about the chain rule, right? And there is one exercise left, chain rule. So let me just remind you what was the exercise. So exercise, I think I solved the first problem, and the problem number 2 and 3, I think I didn't have time to finish number 2 and 3, right? So number 2 is h of x equal to the sine to the power 5 of x, right? And number 3, so your h of x was x squared minus cosine of x, the whole thing to the power 199, right? Actually, number one was sine, so h of x equal to the sine of x to the power 5. Right. Anyway, so of course, the exercise, you have to compute h prime using h prime of x using the chain rule. Right. Well, so let me first remind you the chain rule, right? I mean, actually, there are different ways, of course, to write down derivative. I think someone, yeah, yeah. So there are different ways to represent the derivative or write down the derivative. But so let me just first remind you the chain rule, right? So if you have h of x equal to the composition of two functions, f and g, right? F composed with g of x. Okay, so this is, again, so we read this as f composed with g, all right? And so what does it mean, f composed with g of x? That means that's actually equal, I mean, that's by definition, it's equal to f of g of x. So f of g of x, okay? So when you say f composed with g, that's f of g of x. It's not f of x, it's f of g of x, right? So that's what I call composition of two functions, right? Now, so then h prime, so what's the chain rule? So what does it say, the chain rule? So then the chain rule is, so then h prime of x then h prime of x, right? It's equal to g prime of x, derivative of g, times f prime right? F prime of g of x. Okay, so so that's what I call the chain rule. So this is my chain rule, right? And so, for example, yeah, for number one, like, so I guess I solved number one, but so like for number one, so for number one, so you had to compute. So your h of x is its sine of x to the power 5, right? So it's a sine of x to the power 5, right? So this sine of x to the power 5, it's the composition of two functions, sine of x and x to the power 5. So if you say, let's say f of x is sine of x, right? And g of x is x to the power 5. Then f of g, so then f of g would be sine of, so you have to substitute x by g, right? This x here by g. So that's g of x. And what's g of x? Well, it's the x power 5, right? So that's sine x to the power 5. So, and that's exactly our h. So what I'm saying here is that my h is the composition of two functions, f and g, right? And again, guys, it's because, so you want to compute the derivative of sine of x power 5. We do know the derivative of sine of x, but we don't know the derivative of sine of x to the power 5, right? And so the idea is to write this h as the composition of these two functions, sine of x, because I do know what's the derivative of sine of x, and g of x, which is x power 5, and I know how to compute derivative of x power 5, right? So I know how to compute derivative for f and for g, right? And yeah, and then my h is composition of these two functions, right? So now all I have to do, because my h is composition of f and g, is to apply the chain rule, right? And so what's this chain rule? Well, so in the chain rule, you need, so I want to compute h prime, right? Derivative of h. So in the chain rule, I need g prime and I need f prime, right? F prime of g. So first we said we need g prime, right? Well, my g is x to the power 5. So what will be g prime of x? Well, that's a power rule, right? It's just 5x to the 4th, right? You subtract 1 from the power. All right, so that's my g prime. Next, we said we need f prime. Well, f of x is sine of x. So then f prime of x, so because this is a trig, a sine of x is a trig function, right? And we do know that derivative of sine is cosine. So that's cosine of x. Now, if you take a look to the chain rule, it's not f prime. I mean, it's not f prime of x. So here it's f prime of g, not x, right? So you see this x here. So you need to substitute x by g of x, because we need f prime of g, right? So here it should be, so we need f prime of g. So we need to substitute x, this x here, by g, right? So that's cosine of g of x, right? So that's cosine of g of x is x power 5. So that's cosine x power 5, right? So I got my f prime of g. I have my g prime. So now I can compute my h prime, right? I want to compute this h prime. So then h prime of x. So let me remind you the formula. So h prime of x is equal to g prime of x, f prime of g of x. And so then h prime of x, g prime is the 5x fourth, and f prime of g of x, so times f prime of g of x is this cosine, right? Cosine x to the power 5. So that's cosine of x power 5. All right, so that's the answer. That's my derivative of my function h. Please, guys, I mean, feel free to interrupt me. I mean, if you have questions, I mean, you know, so don't be shy if you have questions, right? But anyway, so you need to know how to apply this the chain rule. But the thing is, with this chain rule, you need to figure out what's the f and g. So because they are not given in the problem. So like now, if we move to the number 2, so number 2, it's h of x equal to the sine to the power 5 of x. All right. Again, this is different from number 1. In number 1, it's a sine of x power 5, right? The power, the exponent here 5. In number 1, here it's x power 5, sine of x power 5, right? And now in number 2, this is a different function, right? Because the power 5 is applied to the sine, not to the x, right? I mean, this is like saying sine of x times sine of x times sine of x, right? 5 times. All right. Well, okay. So this is sine to the power 5 of x. Well, we don't know what's the derivative. I mean, we know the derivative of sine of x, but not the derivative of sine to the power 5 of x. And so, yeah, so the question is, which rule I'm going to use here? Well, so the goal of the exercise, of course, is to apply the chain rule. So we have to figure out, so when I say the chain rule, it means that I need to write h as a composition of 2 functions, f and g, right? So the question is, what's f and what's g in this problem? Any guess what will be f and g in this problem? So again, I want to write h as f of g of x, right? And then I can apply my chain rule. So what will be f and g? Any guess?
F of x equal to x power 5.
Yes. So f, so Ibrahima, you're saying f is x to the power 5. And what about g?
Sine of x.
Sine of x, very good. Because now if you do f of g, so you see here, guys, so if you do f of g of x, right? So if you see, if you substitute this x here by g of x, this x here by g of x, so let me here put g of x, and then you have power 5, right? So that will be my g is sine, so that's sine to the power 5 of x. Okay, and that's exactly my h, absolutely. So that's exactly my h. So once you know what's the f and g, right? Now all you have to do is to apply the chain rule. But I know, I mean, it's not sometimes it's not easy actually to find the f and g, right? To write your h as a composition of 2 functions. So yeah, so then So if you want to apply the chain rule, then of course, so apply the chain rule. So then h prime of x would be g prime of x, f prime of g of x. Right, so that's my chain rule. Well, so then, well, we need g prime and we need f prime of g, right? So let's start with g prime of x. So we said g of x is sine of x, right? Here's my g of x, is sine of x. So then g prime, well, derivative of sine of x. Well, we do know what's the derivative of sine of x. We proved actually, we computed the derivative of sine of x, right? We said it's cosine of x. So that's cosine of x. Now, what about f prime? Well, so f of x is x to the power 5. So then f prime, the derivative, this is just the power of x. So remember, for powers of x, you put this 5 in front of x and you subtract 1, right, from the power. So that's 5 in front of x times x to the power 4, x fourth, right? So that's my f prime of x. But you see, guys, in the chain formula, it's not f prime of x, it's f prime of g. So between the parentheses, it's not just x, it's g of x. So I need to put g of x between the parentheses. So here I need to substitute. So this is f prime. So here I need to substitute x, this x here, by g of x, because that's what I have here in the formula, right? It's f prime of g. So you need to substitute this x by g of x, right? So here it should be g of x. So that will be equal, there's this 5 here, there's this power 4 here. So 5 g of x to the power 4, so it's 5. So what's g? G is sine, right? So it's sine of x to the power 4. So sine to the power 4. Okay, so that's my f prime of g. All right, so now I got everything I need to compute my h prime, right? This h prime here. So then, so that's the answer, of course. So here's my answer. So h prime of x. So first, it's g prime. Here's my g prime. It's cosine of x times, and then f prime of g. And this is exactly my f prime of g, the 5 sine to the power 4 of x. And I mean, another way to write the answer would be 5 first, cosine of x, sine to the power 4 of x, right? So I just wanted to put the number, the constant 5 first, right? So that's the final answer. So yeah, you see, guys, the difference between number 1 and 2. In number 1, this is, you know, it's in number 1, it's a sine of x power 5. So it's f of g. So f is sine, g is x power 5. Now in number 2, that's the power 5 of sine of x. This is here, this is like saying this is power 5 of sine of x. So that's my f of g. Okay. Any question, guys?
Professor, can you
Yes.
go back up so I can see? Can you go back
Number
up?
1, up.
No.
Okay.
No, all the way to the beginning of the page on top when you first did number 5 for the homework.
Oh, okay.
Oh,
that's so then that would be the previous page then.
Yeah, because I'm kind of getting it now. Because you have to use the quotient rule, the f prime g
Okay.
minus g prime.
Okay. let me see here. Okay, here. All right, I guess problem, which problem you said? The problem 6 or?
The first one. The first
Oh,
one.
the first one. Oh, okay, here. This one, right?
Yeah, you know, the one you did with problem 5.
Oh, problem 5, sorry. I thought you were talking about problem 1. Yeah, here.
Can you just shrink it a little so I can see everything?
Okay. Sorry, I'm using my
Okay.
iPad and sometimes
you.
it's not. Anyway,
So-
guys, so
So I have a question.
Yeah, sure.
Sorry, Professor. When you do that, do you have to simplify it all the way? Or can you just leave it? Do you want it as that answer? Or do you want us to continue to see if you can, what do you call it?
Simplify.
Yeah, that's what I'm doing, unless you want us just to leave us the
No,
answer.
I mean in the homework, does it say simplify your answer? Yeah, find and simplify the derivatives. Yeah, so you need to simplify if it's possible. I mean, sometimes it's not just there's nothing you can do, but if it's possible, yes, you have to try to simplify your answer because it's in the problem, right? The problem says find and simplify the derivatives, right?
Okay.
So yeah, if it's I mean, sometimes it's possible, sometimes it's not, right? So it depends. So like here, I would say, like here, it's not possible. I mean, even if I distribute everything, there's no conciliation or anything, right? So it depends on the problem. Sometimes it's possible to simplify, sometimes it's not. So this is like here, that would be fine answer because there's no more simplification. But the problem number 6, you see, because in the problem number 6, when you distribute, you see there's the cosine square plus sine square, and I know that will be equal to 1. So that's a possible simplification, right? So then, yeah, so then I have to simplify my answer. So
Okay.
yeah. Anyway, so are you done with this page?
Oh yeah. Thank you.
Okay. Oh, okay. Sure. All right. Well, so let's continue with the chain rule. So that's problem number 2. Problem number 3, guys. Problem number 3. So we have, I think it's, sorry. So I think we have, where's problem number 3? It's, yeah, x squared. So h of x, it's x squared minus cosine of x, and the whole thing to the power 199. Right? So yeah. So of course the goal is to apply the chain rule. So we need to find f and g such that h of x would be f composed with g, right? So we need to find f of x and g of x such that h of x equal to f of g of x, right? So any guess for f and g? So what will be f and g in this case? Yes, Adrian. So f would be the power 199. So f, yeah, absolutely. F is the x to the power 199. And what will be g? So then the g would be, the x squared minus cosine of x. All right. So so if you do, yeah, Ibrahima, yeah, x squared minus cosine of x. Yeah, thank you. So if you do f of g of x, So if you substitute this x here by g of x, so then that will be, so this x here by g of x. So here's my g of x, x squared minus cosine of x, right? And then, so this is my x. So I substitute x by g of x, and then there's this power 199. Right? So yeah, so f of g of x would be exactly my h of x. Right? So yeah, so then we have to apply. So once you find your f and g, then we can apply our the chain rule. Right? So then, you know, h prime of x, it's g prime of x, f prime of g of x, right? So we need g prime of x. So g of x is, we said it's x squared minus cosine of x. So then g prime of x, that will be equal to, now here guys, it's not a quotient, it's not a product, it's just a subtraction. So if it's a subtraction, there's a minus here, right? So all you have to do is to compute the derivative of x squared, and then minus, and then derivative of cosine of x. So derivative of x squared, power rule, that would be 2x, right? Put the 2 in front of x and decrease the power by 1. So that's 2x, and minus derivative of cosine, it's minus sine. All right. So then your g prime of x is actually 2x minus minus, that would be a plus sine of x. Okay. So yeah, so I got my g prime of x. Now what about f prime of g of x? So first I need f prime, right? So my f of x, so f of x is the x to the power 199. So then f prime of x, so you put the power, you bring down this power here in front of x, so that will be 199 x to the power, and then you subtract 1, so then that will be 198, right? But this is f prime of x, it's not f prime of g of x. We need f prime of g of x in the formula, right? So now we need to find f prime of g of x. All right, so just substitute x. We need to substitute this x here by g of x. So I need to substitute this x here by g. So that will be 199, and then I have my g. So my g is x squared minus cosine x. And then I have this power 198, right? So then I got my f prime of g of x, all right? So then h prime, okay, so now we'll find the answer. H prime of x, that will be g prime. So here's my g prime. It's the 2x plus sine of x times, and then there's this f prime of g of x, so it's times 199 x squared minus cosine of x to the power 198. Okay. In other words, h prime of x, it's 199. I'll just move the number in the front. 199 2x plus sine of x times x squared minus cosine of x to the power 198. Right? I just moved this 199 to the front here. Right? Any question, guys? So I guess in the homework number 7, so tomorrow in the homework number 7, you're gonna have a lot of a lot of problems about the chain rule, because I think one of the most difficult most difficult rules in the for the derivatives is the chain rule, because in the chain rule you have to figure out what's the f and g, right? I mean, if you have like a product rule or quotient rule, that's kind of, it's not that bad, because when you have a quotient, then you know you have to apply the quotient rule, and if you have a product, you know they have to apply the product rule, right? But for the chain rule, sometimes it's not obvious, because you need to find your f and g, right? You need to write your h as the composition of f and g, right? So and actually, last time I talked about some consequence of the chain rule. So instead of using this chain rule for this function h, we had, so let me just remind you this corollary. So we said if you have h of x equal to some function g of x to the power n, so your g is g of x to the power n, then, so this is a consequence again of the chain rule. Then h prime of x, it's just n. So you put this n here in front, and then times g prime of x, okay, and then times g of x to the power, and you subtract 1 from the power, so it's power n minus 1. Okay. So whenever you have some function to the power n, whenever you have a function to the power n, right, then you can apply this rule here, this one here. And again, this is a consequence. I think we proved this last time, right? So this is a consequence of the chain rule. So for example, if I come back to my exercise, to my h of x, which is so number 3 here. So my h of x was, x squared minus cosine of x to the power 199, right? So this is like, so my n, this n here, that will be this power 199, so that will be my n. And this thing here, x squared minus cosine of x, that's my g of x. Right? So I have this x squared minus cosine of x to the power 199, right? Now, if you wanna apply this formula instead of using the chain rule, then you can say then your h prime is supposed to be equal to, well, first n, right? And what's n? The power n, it's 199, right? So here's my 199 times g prime, right? This is g prime here. So what's g prime? Well, g of x is, g of x is x squared minus cosine, right? So then g prime, derivative of x squared, of course, is 2x minus derivative of cosine is minus sign. So minus minus, that would be plus sign, right? So it's plus sign of x. So so this g prime of x would be 2x plus sine of x, right? And then the last term in the formula is this g of x to the power n minus 1. So what's my g? My g, it's the x squared. It's the x squared minus cosine of x. That's my g, right? And then we said it's to the power n minus 1. So n is 199, right? 199 minus 1, of course, is 198. So you see, guys, we got the same answer. If you compare this to the previous answer, here, our answer, this was our answer, right? 199 times 2x plus sine of x times the x squared minus cosine to the power 198, right? And it's exactly the same answer, right? So all I'm saying is, whenever you have a function to some power, okay, like here, x squared minus cosine to the power 199, then all you have to do is just, you can try to apply this formula, which is consequence of the chain rule. Right? Any question, guys? Okay, well, so otherwise I have actually kind of bad news, right? So the bad news is that we're gonna extend the chain rule to 3 functions, right? I mean, our chain rule is, is the composition of 2 functions, f and g, right? So we try to write h of x as a composition of 2 functions, f and g, right? F composed with g. Now, the question is, what about if we compose 3 different functions, not just 2, 3 different functions, like let's say f, g, and k. All right. So what will be the derivative? Okay. So yeah. So that's. So now we're gonna extend. So I'm probably gonna move to the next page, unless there's a question about this example. Nope. Okay. So we're gonna extend the chain rule to 3 functions. So let's say now you have let h of x equal to f composed with g composed with L of x. Okay, so in other words, h of x is f of g of L of x. Okay, so for example, let's do an example so you can see examples. So let's say my h of x is sine of cosine of x squared. Right? For example, what would be h of, let's say, square root of pi over square root of 2. Okay, so that will be sine of cosine of, so this square root of pi over square root of 2 squared, right? So guys, here you have to apply, so PEMDAS rule. So first, you start from the inside, right? So inside, you have this this square of square root of pi over square root of 2, right? Now, so what would be square of square root of pi over square root of 2? So you apply the square and the square root, they cancel out, right? This square here and this square root, they cancel out. So this is actually sine of cosine of pi over 2. Okay. So again, now I have to do the next parenthesis inside. So here inside the parentheses, I have the cosine pi over 2. So I have to compute cosine of pi over 2, right? So cosine of pi over 2, of course, that's pi over 2 is 90 degrees, right? So cosine of 90 degrees is just 0. So that's actually sine of, so this is sine of 0. And then I have to compute sine of 0. So since the sine of 0 is actually 0, so the answer here would be 0. Anyway, my point here is that you see here, the way you read this function h, it's sine of cosine of x squared. So this is like f of g of L of x, right? So then, then your f, so what will be L? Let's start with L, let's say. So L of x, so my L of x would be x squared, my g would be the cosine, and my f is the sine, right? So L of x is the x squared, my g of x is the cosine of x, and my f of x is sine of x. Right? The sine of x. So, and of course, you want to compute what will be then f of g of L of x. Well, so then f of g of L of x. Well, we start with, let's say, g of L of x. So what's g of L of x? Right? Just to substitute this x by L of x, right? By the x squared. So g of L of x is just, it's cosine of x squared. That's g of L of x. Now, what's f of g of L of x? So, my f of x is just sine of x, right? Now, you want to compute f of g of L of x. So we need to substitute this x in here by this g of L of x. And we just said g of L of x is cosine of x squared, right? So I need to substitute this x by g of L of x. So then that will be sine, and between parentheses, I'm going to have g of L of x, which is cosine of x squared, right? And that's exactly my h of x. Okay. Okay, so here's an exercise, guys. I'm gonna give you some functions, and you have to write the functions as composition of 3 functions. All right. So exercise. Okay. So 1. So let's say h of x is equal to, let's say, log of sine square of x, right? 2, let's say h of x is equal to cosine of exponential of 2x, right? So the question is the following. So find f of x, g of x, L of x, such that, right, h of x would be equal to the composition of the 3 functions, such that h of x is equal to f of g of L of x. All right. So here what I'm saying, guys, is that my h, it's composition of 3 functions, f, g, and L. And so we have to find those functions, f, g, and L, right? So I'm going to give you, let's say, 5-10 minutes to think about this exercise. Please let me know if you need any help, any question, please let me know, all right?
Professor,
Yes. Mhm.
we just need to find the value of f, g, and l.
Yeah, only, yeah, don't compute the derivative. Actually, we don't know, again, we don't know yet the derivative of log and the exponential. Yeah, all you have to do is just find the f, g, and l.
Okay. So f equal to log of x.
For number one?
Yeah.
Mm-hmm. Yeah, absolutely, yeah.
Z equal to x squared.
Yep, well, very good.
And L sine of x.
Yes, absolutely, yes, very good. What about number two? Any idea for number two?
No, yeah.
Okay. Yes, correct, Elias. For number two, f is cosine, yes. Mhm. Yep, yes. G would be e to the x, yeah. Mm-hmm. Yes, correct, absolutely, yeah. Yes, very good. Yeah. So yeah, I mean, it's just about how you read the, your function h. So for example, for number two, I mean, you wanna write h as a composition of f with g and l. So this is f of g of l of x, right? So like here, for number two, you have cosine of exponential of 2x. So then your cosine, that's your f, the exponential, that's your g, and the 2x would be your L, right? For number one, it's so it's a log of, well, it's sine square of x, but how, so the thing is, how do we read sine square of x? It's not sine of 2x or sine of x squared. It's the square of sine, right? So it's log of the square of sine, right? So then the log would be your f, the square, x square, that would be your g, and the sign would be your L. So yeah, so okay, so let me write it down here. So for number one, if you say f of x is equal to log, that's your first function, right? First function, that's f, right? Here f, it's the first function. So log, you have log first, so that's f. So f is log of x. Now, next function, it's not really sine, right? Because again, it's log of the square of sine. So the second function is actually square, x squared. So g of x should be x squared. And the third function, L of x, that's sine of x. So then you wanna find f of g of L of x, right? So how do we find such thing? Well, first, it's by steps. So first, step one, you need to find g of L of x. So g of L of x, right? You know, g of x, we said it's x squared, right? So what would be g of L of x? So we have to substitute x. So this x here is x by L. So that L is a sine of x, right? So then that will be sine square of x. That's g of, that's equal here, of course. So that's g of L of x. And then the next step, we can compute f of g of L of x. So you know, f of x is log of x. So then the question is, what will be f of g of L of x? So you need to substitute x, this x here, by the g of L of x. So this x here by the g of L of x. Here's g of L of x, right? It's the sine square. So that's log of g of L of x. So it's log of sine square of x. Right? Again, the main, I would say the main thing here is, you know, to find the f, g, and L, right? So for number two, we said, so first function f, so f, that will be the first function, and the first function here, you can see it, it's just cosine, right? That's my first function f. So it's cosine of exponential of 2x. So that's f of g of L. So cosine is f, g is exponential, and L is the 2x. So for number two. So for number two, so f is cosine, right? And then we said the second function, g, is the exponential. So g of x is exponential of x. And then finally, L of x is the 2x, right? So if you do, if you want to compute f of g of L of x, so first we need to find, you know, g of, so step one. So if you want to compute, well, first you start with g of L of x. You know that g of x is e to the x, right? So we have to substitute x by L of x. So this x here by the L of x. So that will be e to the L of x. So that will be e to the 2x. All right. That's my g of L of x. And then what will be f of g of L of x? So step two. So then f of g of L of x Well, f of x is just cosine of x, right? That's my f of x. Now I need to substitute x, this x here, by g of L of x. So this x here by g of L of x. So, and g of L of x is the exponential of 2x, right? So that's, here's cosine, and here is going to be e to the 2x. That's my g of L of x. And that's exactly, of course, that's exactly my h of x. Anyway, guys, I mean, this is an exercise, you know, just to, I know it's not sometimes, I mean, it's not really obvious, easy to find these the three functions, f, g, and l. But again, it's just about, you know, the way you read your function. So first function should be f, second function should be g, and then the third function is l, right? Anyway, so yeah, is there any question, guys, about this exercise? Okay, so let's take a break of 5 minutes, and then after the break, so we're gonna do, of course, we're gonna compute the derivative of the composition of the three functions. Okay, so we said we're gonna extend the chain rule to three functions, right? So we're gonna compute the derivative of the composition of three functions. So yeah, let's take a break of 5 minutes. And we'll continue with the chain rule extended to composition of three functions, right? So I will be back at 7:45, right? So let's take a break of 5 minutes, right? So I'll be back. All right, guys. So yeah, so let's continue with the chain rule with the three functions. Again, so we are extending. So we are extending this chain rule. So we have so h of x equal to, so f of g of L of x, right? Then h prime of x, the derivative, h prime of x. Okay, so the idea is actually to apply the chain rule 2 times. So we're gonna have first L prime of x, right, times g prime of L of x, right, times f prime, right, f prime of g of L of x, right? So f prime of g of L of x, right? So I mean, so the idea is, I mean, the proof or the idea is the following. So why do we have such formula? Well, it's because of the following. So you know, so you have your h of x, which is, we said it's f of g of L of x, right? So let's call g of L of x, this function here, g of L of x. So let's call this function u of x, right? So my u of x is the g of L of x, right? So what I'm saying is I'm gonna write h of x as f of u of x, right? My u of x again is u of x is the g of L of x, right? So if you want to compute h prime, well, so now I have just 2 functions, right? My h is composition of 2 functions, f and u, right? So, and we do know how to compute the derivative of the composition of 2 functions, right? So that will be equal to the derivative of the function inside here. So that's u prime of x times f prime of u of x, right? So imagine if you have like f of g of x, so the derivative would be g prime, the derivative of the function inside the parentheses, g prime f prime of g, right? But here instead of g, we have u, right? Instead of g, we have u. So, but anyway, we can still apply our formula, right? So now the question is, well, I know that u of x, it's g of L of x, right? So here you can see I have my f prime of, because u is, again, u is g of L of x, right? So here, this is just f prime of g of L of x. So I got this term here, this one here, right? Now, what about u prime of x? So what's u prime of x? Well, I mean, u of x is, u of x is g of L of x, right? So then the derivative u prime, so it's a composition of two functions, right? So then u prime, it's the derivative of the function inside the parentheses, so it's L prime of x times g prime of L of x, right? It's like saying f composed with g derivative, it's g prime f prime of g, right? So I'm applying the chain rule here. So that's my u prime, right? So now I can write down my h prime. So here's my h prime, supposed to be u prime times f prime of u. So then my h prime would be, so then h prime of x would be u prime, and u prime, we just said u prime is L prime of x times g prime of L of x, right? And then there is this f prime of u. So that's f prime of, and u, we said it's g of L of x. So that's f prime of g of L of x. Okay. And so that's exactly my formula here, right? Again, the formula, the derivative of the composition of three functions was this, this formula here, right? Right here, right? Anyway, so let's try to apply this formula. So here's an example. So let's say my h of x is equal to cosine of sine of x to the power 4. Okay. And of course, the question is, you want to compute the derivative, h prime. So this cosine of sine of x to the power x fourth, it's a composition of three functions, right? This is like f of g of x fourth. Okay, or f of g of L, right? This is here, this is f of g of L of x, of course, right? So so the question is, yeah, so what's the h prime? So first, so we said f of x, so f would be cosine of x, right? My f is the cosine of x, my g is the sine of x, and my L of x is the x fourth. So again, be careful, guys. I mean, this is not cosine times sine times x fourth. This is cosine of sine of x to the power 4. Okay, so just, I know it's easy to it's easy to get confused between the composition and the multiplication, right? So multiplication or product, you apply the product rule, that when you have a composition, you apply the chain rule, right? So this is not cosine times sine times x fourth. This is cosine of sine of x fourth, right? So anyway, so my f of x is cosine, my g of x is sine of x. So my g of x is sine of x, and my L of x is x fourth. So L of x is x fourth. And what I'm saying, guys, is that if you do f of g of L of x, well, then that would be equal to cosine of sine of x fourth, right? And so that's exactly my h of x. Right? So my h is the composition of these three functions, f, g, and l. Now, what's h prime? Well, so we said, so the formula we had is the following. So then h prime, so h prime of x is, we said it's L prime of x, g prime of L of x, times f prime of g of L of x, right? That's our chain rule. So this is our chain rule, right? Chain rule. Well, chain rule for when you have the composition of three functions, right? All right. So so we want to compute is h prime. So first we need first we need L prime, right? So what's L prime of x? Well, L of x is x fourth. Then L prime of x. So you bring down this 4 in front of x, so you subtract 1. So L prime of x is 4x cubed, right? So that's L prime of x. Now next, we need g prime of L of x. Well, first let's start with g prime of x. Well, g of x is, so g of x is it's sine of x, right? Here's my g of x. This is my L and this is my f. So my g of x is sine of x. So g prime of x, derivative of sine of x, we said it's just cosine of x. Now in the formula, I need not just g prime of x, I need g prime. You see here, I need g prime of L of x. So I need g prime of L of x. So I need to substitute x by L of x. This x here by L of x. So this x here by L of x. So then that will be cosine of L of x. So it's cosine of x fourth. Right? Because L of x is x to the power 4. X fourth. Right? Now, okay, so that's good. That's g prime of L of x. Now next, we need f prime of g of L of x, right? So let's start first with g of L of x. Right, so here inside f prime, I have g of L of x. So what's g of L of x? Well, so here, so we need, well, g of x is sine of x, then, g of L of x, that will be equal to, so you have to substitute x by L of x. So this x here, this one here, this x here by L of x. So then g of L of x would be sine of x fourth. My L, again, my L is x to the power 4. So then g of L of x is sine of x to the power 4. Now, again, in the formula, we need f prime of g of L of x. So first, what's f prime? Well, f of x is, we said f of x is cosine, right? Here, f of x is cosine. So what's f prime? So f of x is cosine. F prime is minus sine. But then we need f prime of g of L of x, right? F prime of g of L of x, right? So we need to substitute x, this x here, by g of L of x. So this x by g of L of x. So we have minus sine. And then, so what's g of L of x? We just said, you know, here, we just said that g of L of x is sine of x fourth. So here we're going to have sine of x fourth. So f prime of g of L of x is minus sine of x fourth. Minus sine of x fourth, it's not minus sine square. This is not, it's not a multiplication, guys. Again, it's a composition. So minus sine of sine, it's not minus sine square, right? So again, because that's not a multiplication, right? Now, okay, so now I have everything I need, right? I have my L prime. I have my L prime. I have my g prime of L of x, and I have my f prime of g of L of x, right? So, okay, so then I can answer the question. So find answer. So answer. So h prime of x it's equal to, so let's come back to the formula. So first we have, we said L prime of x, and L prime of x is this 4x cubed, right? So first we have 4x cubed. So here's my 4x cubed. 4x cubed times, and then we have g prime of L of x, this here, g prime of L of x. So what's g prime of L of x here? This is g prime of L of x. It's cosine x fourth. So times cosine x fourth. So here times cosine x fourth times, and then we need f prime here, f prime of g of L of x, right? F prime of g of L of x, and here is my f prime of g of L of x. It's minus sine of x fourth. So that's times minus, so times minus sine of x fourth, right? So in other words, I'm going to put the minus in the front. So h prime of x, it's actually minus 4x cubed cosine x fourth sine of x fourth, right? So that's a fine answer. So any question, guys? So yeah, I know this is a lot. I mean, it's so now we have like 3 functions, and yeah, so we have to compose all those functions, and yeah, but you need to know this formula, right? You need to know what will be the derivative of composition of 3 functions, right? So if there's no question about this example, guys, so here's an exercise. So you're gonna have to apply this chain rule, composition of the derivative of composition of 3 functions, right? So exercise. So the exercise is, of course, to compute h prime of x, right? So first, So we have h of x equal to cosine, cosine of sine square of x, or let's say sine square of 2x. Okay. No, let's just say x here. Probably would be too much. So let's say it's cosine of sine square of x. All right. And what else? Yeah, let's just do this one here. Okay. So cosine of sine square of x. Right. So just one problem. So so basically, guys, there are 2 steps. So step 1, you need to find. So the steps would be. So step 1, you need to find f, g, and l. L of x says that h is equal to f of g of L of x, right? And then, of course, the step 2 would be to apply our chain formula, right? So apply our chain formula. Right, so then your h prime should be, L prime of x, g prime of L, f prime of g of L of x. Right? All right, guys, so we have, let's say, 10 minutes to think about this h prime, to find this h prime. So this is L prime of x. So again, guys, here you need to understand that this is, this is cosine of the angle sine square of x, right? It's not cosine times, because when you say cosine, you need the cosine of something, right? So cosine of an angle. So here it's cosine of this angle sine square of x, right? So this is cosine of, it's not cosine times, right? So when you have cosine, it's cosine of something, of an angle. So the angle here would be the sine square of x. So it's cosine of the angle sine square of x. Yes, yeah, very good, Ibrahima. Yes, yeah, excellent. So, I mean, we are almost done with this section. I mean, I think next we will move to the next section. So in the next section, we're gonna, so we're gonna do the derivatives actually of log, logarithmic function, and exponential, right? So after the powers of x, after the trig functions, next, and the chain rule. So we're gonna do the derivatives of log, logarithmic functions, and exponential. Yeah. So this is a section 2.5. So we are almost done with this section 2.5, and yeah. So yeah, I'm gonna do section 2.7, and then I will come back to the next section 2.6. So actually the chain rule would be probably the last, the chain rule, it's actually the main rule when you compute a derivative. And I would say the hardest one, right? So once we are done with the chain rule, then yeah, we are almost done with the derivatives. All right, guys. So yeah, Daniel. So it's section. This is section 2.5. 2.5. Oops. All right, guys. So for step 1, so we need to find f, g, and l such that h is f of g of l of x, right? So I mean, first function, of course. So you see here, first function we start with f, and here we have cosine. So then f, obviously f would be cosine, right? Because that's like the first function. So it's f of g of l of x. So this g of l of x is this sine square of x, right? So my so let's so that this is a step 1, right? So what we are saying is so this is step 1. So what we are saying is that f of x, that will be the first function, which is cosine. So my f of x is cosine of x. And then we said the g of l of x is the sine square of x, right? So again, so this cosine here, that's my f, and this, what's in between the parentheses, that's my g of l of x, right? Now, if my g of l of x is sine square of x, so what's g and what's l? Is it sine of, well, it's a g of l of x, right? So sine square of x, it's not sine of 2x or sine of x squared. It's not sine of x squared. It's the square of sine, right? So this is so this is like the square of sine of x, square of sine, right? It's not sine of x squared. It's the square of the sine. And so this is of the form, of course, g of l of x. So then what will be g? Well, so then g of x would be the square, that's the x squared, and l of x, that will be the sine, or sine of the angle x. Right? So when you say g of l of x, so then g of l of x, right? So you have to substitute this x by L of x, right? This x here by L of x. So then x by L of x. So L is sine, right? So that will be sine square of x. Yeah, so my g is x squared, my L is sine of x, my f of x is cosine. So now so I got my f, g, and l. So now I can move to the step number 2 where I have to apply the chain rule. So now I can move to the step number 2. And I'm gonna apply my chain rule. So my chain rule, again, it's H prime would be L prime, G prime of L, and then F prime of G of L. Right? So first we need L prime. So what's L prime? Where is L? L, we said here. L is sine of x. So then L prime, L is sine of x. So then L prime, derivative of sine is cosine. Next, we need, so in the formula we need G prime of L, right? So first, what's G prime? Well, G of x is x squared, right? Then G prime, of course, that's x. G is a power of x. You bring down the power and you decrease the power by 1. So that's 2 times x to the power 1. So that's 2x. So that's my G of x. But of course, in the formula, I need G prime of L, not just G prime of x. It's G prime of L of x. So I need to substitute x by L of x. So here, this x here, this one here, I have to substitute by L of x. So G prime of L of x would be 2 times, so L is sine of x. So 2 times sine of x. That's 2 sine of x. So that's my G prime of L of x, right? Okay, so I got my second term. Now, what about the third term? So we need this f prime of G of L of x. So do we know G of L of x? Yes, I mean G of L of x, we just said here, G of L of x, it's sine square of x, right? That's my G of L of x, right? So let me write it down here. So G of L of x, not G prime, G, right? G of L of x, we just said it's sine square of x, right? Now I need f prime. So we need f prime of G of L of x, right? So what's f prime? Well, f, we said f is, where is f? F is cosine of x, right? So f is cosine of x. So then f prime, derivative of cosine, it's minus sine. So what's f prime of G of L of x? So then f prime, we need f prime of G of L of x, right? So we need to substitute x. So this x here, you see this x here, we need to substitute the x by the G of L of x. So it's minus sine G of L of x. What's G of L of x? We just said that G of L of x is sine square. So it's minus sine of sine square of x. All right. Well, so now I got everything I need to compute my h prime. So then my answer, final answer. So then h prime. So first, h prime, we need L prime. So this is equal to, so L prime, so what's L prime? L prime is the cosine of x. So it's cosine of x times, and then G prime of L of x. So here is G prime of L of x is 2 sine of x, so times 2 sine of x times, and then we have the, the f prime of G of L of x. And what's f prime of G of L of x is this minus sine of sine square of x. So here it's times minus sine of sine square of x. So let me just move the minus and the 2 to the front. So then, so final answer, so my h prime of x would be minus 2 cosine of x, sine of x, sine of sine square of x. All right, so that's the final answer. All right, I know, I mean, this looks like a kind of crazy, but yeah, so that's, anyway, so yeah, but this is the rule for the chain rule when you compose 3 functions, right? Any question, guys? So I guess in the homework tomorrow you're gonna have some exercise problems about this chain rule, right? Either when you have like composition of 2 functions, or when you have like a composition of 3 functions, right? Any question, guys, about the chain rule? All right, so then let's move then to the section 2.7. I'm going to move to the next section 2.7, and then I will come back to the next section 2.6, right? So I prefer to do the derivative of the logarithmic functions first, and then we can do the section 2.6. So yeah, so let's move to the section 2.7. So we're gonna, in section 2.7, so we're gonna compute derivatives. So after powers of x, trig functions, now we're gonna do logarithmic functions and exponential. Logarithmic functions. Exponential. Okay. So I'm gonna start first with the exponential, with the derivative of exponential. So let me show you how to compute derivative of exponential. So well, what's the exponential function, guys? So let me just first remind you. So let's say f of x. So f of x. So when you write some number a to the power x, right? So this is exponential function with base a, right? So a, so where a, so a here is supposed to be is a real number, right? And so this is exponential with base a, right? So f of x equal to the a to the power x. That's the exponential function with base a, right? Is the exponential function with base a, right? So for example, when you say 2 to the power x, examples, so f of x 2 to the power x, or your a could be, of course, a fraction, for example. So f of x equal to, half to the power x, right? So it's just, it's a number, some number to the power x. Actually, the number should be positive. But anyway, so it's some number to the power x. That's an exponential function, right? So that's the definition, right? So the base, so like when you say 2 to the power x, the 2, that will be the base, right? So this is of base. So 2 to the power x, it's of base 2. Of base 2, and half to the power x, that's base, of course, half, right? That's the definition of exponential function, right? Of course, there's the e to the x. That's a e, when you say e to the x, so another third example, f of x equal to the e to the x, right? So here the base is e, right? So e here is very special. It's a special number, and so of base e, right? So e is supposed to be a number which is approximately. So this e is approximately 2.71, I think, something, right? Anyway, but I'm gonna actually define in a couple of minutes. I will show you how to define this number e. But anyway, so that's what I call the exponential function, right? Now I want to compute the derivative, right? I want to compute f prime of x. So we want to compute. We want to compute f prime of x. Right? Again, f of x is this a to the power x, where a is a fixed number, right? It's a constant. A is a number, right? We want to compute f prime of x. So here, guys, so be careful. Here we cannot apply, the rule we have for the power. I mean, this is not x to the power n. This is some number to the power x. So this is different from. So here we cannot apply. We cannot apply the rule for x to the power n, because when you have x to the power n, so here x is the base, right? X, the variable x here is the base, right? Well, if you have a to the power x, x is the exponent, it's not the base. Okay. On the other hand, so because we cannot apply the power rule, because in a to the power x, the variable x is the exponent. It's not the base, right? Is the exponent. Okay, so we cannot just say it's like x times a to the power x minus 1, right? So we cannot really apply the rule for x to the power n, because x here, it's not the base, x is the exponent. So does it make sense to you guys why we cannot apply the rule, the x to the power n to this a to the power x? So you see the difference, right? I mean, a to the power x, x is the exponent here. So this is really important, right? So here in the exponential, the x is the exponent. When you have x to the power n, x is the base. It's not the exponent. So we cannot apply the same rule. It's not the same thing, right? Anyway, so yeah, so we want to compute the derivative, right? So let's see what happens when we compute the derivative. So my f of x is a to the x, right? And so we want to compute f prime of x, right? So we have to use the limit definition of the derivative, right? So remind you the limit definition. So it's limit h going to 0, f of x plus h minus f of x over h, right? That's the definition of the derivative, right? But here, so what's my f? F of x is a to the x, right? And so what will be f of x plus h? So just substitute this x here by x plus h, right? So that will be a to the x plus h. right? So my f prime, so what I'm saying is that my f prime of x is limit h going to 0. So f of x plus h, I just said f of x, this f of x plus h here is a to the power x plus h, right? So this is a to the power x plus h. Then there's a minus, so here's my minus. F of x, it's just a to the x over h, right? So what can we do here, guys? Well, you can see here there's a to the x, which is actually a common factor because so the thing is, you can write a to the power x plus h as a to the x times a to the h. So I mean f prime of x, that will be limit h going to 0. So this a to the x plus h, I can write like a to the x times a to the h, right? Because when you have the same base, you can add the powers. So the base here is a. So then you add the powers. So that will be x plus h. And then, so minus, this is minus a to the x over h, right? So why I wrote this a to the x plus h as a to the x times a to the h, because now you can see this a to the x as a common factor, right? This, you see this a to the x, a to the x. So that's a common factor. So we can factor out this a to the x. So we have f prime of x equal to, so this a to the x is a common factor. It doesn't depend on h. So here's my a to the x. And then times the limit a to the h minus. So if you pull out this a to the x, if you pull out this a to the x, then you are left with, of course, here it's 1, right? It's 1 times a to the x. So it's minus 1. So this is minus 1 over h, right? So again, guys, all I did here was to factor out this a to the x, right? I just pull out the a to the x. All right, so here's my a to the x. Now, so now I got this a to the x times this limit of a to the h minus 1 over h. Well, so my claim is that, so this thing here, this limit a to the h minus 1 over h, that's exactly f prime of 0. You see, if you replace here x by 0, f prime of 0, you replace this x here by 0 and this x by 0. So you're going to have a to the h minus a to the 0 over h, right? So that would be f prime of 0. So what I'm saying, guys, is that, so this is a claim. So f prime of 0, well, by definition, it's supposed to be limit, h going to 0, a of 0 plus h, so it's a to the h minus f of 0. My f of x is, my f of x is a to the x, right? That's my f of x. So f of 0, that will be a to the 0, minus a to the 0, right? Over h. And that's exactly limit h going to 0, a to the h minus 1 over h. Right? So all I'm saying, guys, is that this limit here, this is exactly f prime of 0. So this is f prime of 0, right? We have the same thing, right? That's the same thing here, right? It's f prime of 0. So the conclusion is that f prime of x, so we are trying to compute f prime of x, right? So then f prime of x turns out to be, conclusion, so f prime of x turns out to be a to the x times f prime of 0. Okay, again, f of x, where f of x, of course, is a to the x. Right, that's my function f, right, my exponential function. So what I'm saying is f prime of x is a to the x times f prime of 0. And so in other words, f prime of x is actually f of x. And so in other words, f prime of x is equal to, so this a to the x, that's exactly my f of x, right? That's my exponential function. So f prime of x is equal to f of x times f prime of 0. Right? Okay. Now, by definition of the number exponential of the number e, so so this is the definition actually. So by definition, yes.
Can you move a little bit to the left?
To the left,
Yeah.
like this.
Yeah, that's fine.
Mm-hmm. Sure. Yes, so guys, so I was saying, yeah, so the function f is the exponential in base a, right? And I got this relation here, right? I'm saying my f prime of x is actually equal to f of x times f prime of 0, right? Where f, again, f is my exponential function, right? But actually, by definition of the number e, definition of e to the x. Okay, so this is the definition of the number e, is that, so this is when, f prime of 0, f prime of 0 is equal to 1. So that's exactly the definition of the number of the number e. So that's when the f prime of 0 is equal to 1. Okay. So in other words, what I'm saying is that so what we are saying here is that so we're gonna have the following rule. Okay. So when the base a is equal to the number e, f prime of x is equal to f of x. Okay, so the derivative of the exponential function in base e is going to be equal to the same function. So when the number a is equal to e, then the derivative of the exponential function is going to be equal, f prime of x is equal to f of x. Okay, so it's equal to the exponential of x, right? So what we are saying here is that the derivative of the exponential function in base e is equal to the same function, is equal to the e to the x, right? Right, and actually, so that's the first rule number 1.
Professor.
Yes.
You said by definition of f of x equal to exponential of x is f prime of 0 if f prime of 0 equal to 1.
Yeah, if f prime of 0 is equal to 1, yes.
Okay.
That's when the f prime of 0 is equal to 1.
Okay, thank you.
Yeah, so what we are saying is that by definition, actually, definition of the exponential function in base e, that's when the function f is equal to its derivative. So, I mean, I don't know how they introduced the exponential function in pre-calc, but that's the way we define the exponential function in base E. So that's when the derivative of the function is equal to the function itself. Okay, so so the derivative of e to the x is just e to the x. So so in other words here, let me just write it down here. In other words, derivative of e to the x, so the derivative of e to the x is equal to the e to the x. Okay, so this is I mean, this is the definition actually of the again exponential of x, is that the derivative of the function is equal to the function itself. In other words, this f prime of 0 is equal to 1. Right? Now, if you have a different base, if the base is not, so in general, so rule number 2, so in general, if you have a base different from E, so in general, so derivative of a to the x, so this is equal to actually, well, a to the power x times the natural log of a. Okay. So here, guys, when I say natural log, that's the log in base E, right? So where natural log of x, that's the log, you know, in base E of x, right? That's so this is a natural log, right? ln is the natural log. Okay. So anyway, I guess, oh wow. Yeah, so I guess probably I'm gonna stop here. I mean, this is just so this is section 2.7. We are doing derivative of a log, exponential, etc. Yeah, so I will come back to this next time anyway. So I have to do the derivative of a log, derivative. So this is derivative of exponential functions. But yeah, but next time we're gonna do, of course, the derivative of a log and etc. So anyway, guys, I'm gonna stop here, and I guess I will see you next Monday, right? And I will post the homework number 7 tomorrow, right? As usual. Well, take care, guys, and good night. Thank you, everyone.
Professor, I have a question.
Yes. Yeah, sure. Please.
Where you said on the last part.
Which part?
The last part of
here in general.
Yeah.
Mm-hmm.
Where you said ln of x equal to log exponential of x.
This thing here.
Yes.
Mm-hmm. Yes.
So exponential is the base and then power of x. That's what you meant.
No. So what I'm saying here is that when you, because in general, I will define next time, but when you have a log, so when you have a log, you have a base, right? You say log in base a of x, right? But so when you have natural log, that's the log in base e, the number e, the 2.71, etc. That's the log in base e of x, the natural log.
So ln equal to log base e of
yeah, ln of x. Sorry, here is should be ln of x. This is sorry. This should be ln of x here. This is ln of x, of course. So you know the definition of log in base a of x. So that's, you know, you have, so let's say this is equal to y. y is log in base a of x, it means that this is equivalent to, you know, a to the power y is equal to x, right? That's the definition of log in base a of x. So if it's equal to y, then it means that a to the power y, this a, the base, this base a, to the power y would be equal to x. But this is like definition of logarithmic function, right? So I'm going to talk about this, I guess, next time. That's the definition of a logarithmic function.
Okay, thank you.
Does it make sense to you, Ibrahima?
Yeah, understand.
So this natural log, that's the log in base e, the number e in base e of x.
Okay.
I will talk about log next time anyway.
Okay, thank you.
Thank you so much.
All right.
See you next Monday. Take care. Good night, everyone. Thank you, everyone.